Let's start by taking a little bit of a review of algebra. So this would be past work that you've done in grade 9. And just to make sure that we're all on the same page, let's go over a few things. Let's begin with substitution. So substitution is when we take some kind of a value of a variable and we substitute it into the expression in the appropriate place. So in these examples, we're going to take a look at if x is equal to 2 and y is equal to -1. So if we take a look at our first example here, wherever there is an x, let's replace it with a 2. And wherever there is a y, let's replace it with a -1. So notice that I put these in brackets. And the reason why I do that is because we want to remember that when you have a coefficient, which is your number, and your variable, which is your letter, these get multiplied together. So this is really 4 times x. So in this case, 4 times 2, which is 8. And then I have minus 9 times y, so 9 times -1, which is going to be a -9. All right, and we know that when we have two negatives, it really means positive. So that's the same thing as 8 plus 9, which would be 17. Okay, so let's take a look at B. And same thing, wherever there's an x, I'll put in a 2. So 5 times 2 plus 5 times -1 minus 2 minus 7 times a -1. Okay, so wherever there was an x, we put a 2. Wherever there was a y, we put a -1. All right, so 5 times 2, which is 10. Oops, I'm just a little bit frozen here. Whoops, just do that. Okay, 5 times 2, which is 10. 5 times -1, which is -5. -2. And -7 times a -1, which will give me a +7. Of course, you could look at that as you could put your negative and then go 7 times -1, which is -7, and you'd end up with that double negative again, like we did in that first example, which just means plus. So we can kind of do that in one step. -7 times -1, +7. Okay, 10 minus 5 is 5. Minus 2, which is going to be 3, plus 7, which gives me an answer of 10. All right, and then this last example, 2 times 2 minus 3 times -1 minus 6 times 2 plus 12 times -1. And we end up with 4, -3 times -1, which is plus 3. -6 times 2, which is -12, and 12 minus 1, which is -12. Okay, so 4 plus 3 is 7. 7 minus 12 is -5. -5 minus 12, which is going to give me a -17. Okay, so it's just about, putting it into the appropriate spots. And of course, realizing when you have a number, a coefficient, and a variable side by side, it means multiplication. Now, collecting like terms, we need to remember, so like terms, we need the definition of like terms. So that's going to be when your variable and exponent, whoa, I don't know what that was. Just erase that. Variable and exponent are the same. Okay, so if I was taking a look at this first example, I see that I have x's here, so a 4x and a 5x, which would give me 9x. And then I have, let me just do a different color here, I have a 2y and a minus 9y, so that becomes -7y. So the answer to this, if I collected my like terms, would be a 9x and a -7y. try this one. Okay, so we have a 3x and a negative x. So there's no number in front of that x. We're going to consider it a 1, negative 1. So 3 minus 1, which is going to give me 2x. And then I have plus 5x squared minus 6x squared. So 5 minus 6, which is negative 1x squared. Now, of course, we don't have to put the 1, so this could be written just like this. I want you to notice, though, our bases don't change here. So when we add our x's together, I still have that variable x. That does not change. And when I added my x squares together, same thing. It stayed as x squared. So be very careful on that. I know a lot of times people are compelled for some reason to try to combine these two together, and you can't do it. This is an x, this is an x squared, which makes them two totally different things. We cannot put them together. So just be very careful of that as you're doing these like terms. Oh, this is a big long one. So here we go. All right, so feel free to pause the video here and give this one a try and come back. All right, so now we're back. We have an AB, so there's no number there, so that's like a 1, and I have a 6BA. So because this is multiplication, whether or not you write it as AB or BA, it means the exact same thing. So these are the same terms, okay? Same here, 2BA and 8AB. All four of those are all the same. So order does not matter with multiplication. If you think about it, it's like if you go 2 times 3 is 6, but if you go 3 times 2, you also get 6. So it didn't matter if you went 2 times 3 or 3 times 2, you got the same answer. And it's the same thing for variables. We can go AB or BA, and it means the same thing. Normally when we like to write our variables out, though, we always like to kind of go in alphabetical order. But I threw this one in here just to show you that it is the same thing. So 1 plus 6 is 7, 8, 9, plus 8. So that's going to be 17 ABs. And then we have 4a squared b and 7a squared b, which would give me 11a squared b. Okay, so whenever you're trying to put your like terms together, you're looking for the variable. The variable has to be the same, and the exponent on them has to be the same in order to put them together. Okay, so exponent laws, we need to remember a little bit about exponent laws. So let me actually just kind of flip to a new page here for a minute. So when we talk about exponent laws, we're going to talk about, we have a base, so let's call that B. That'll be like the big number. And then you have an exponent, and we can say that that's an M. So when you're multiplying and your bases are the same, so notice B and B, what we can do with our exponents is we can add them together. Okay, so for example, if you had 2 cubed times 2 to the 4th, then that would be 2 to the 7th, because we add 3 plus 4, which gives us 7. Notice the base stays absolutely the same. Okay, so we are not changing our base at all. When we're dividing, so we have our base to our exponent. So division can look like this, or division can look like this. It doesn't matter. It's the same thing. You're going to take your base, keep it the same, but you're going to subtract your exponents. So in this case, let's say we had 2 to the 7th divided by 2 squared, then that would be 2 to the 5th, because 7 minus 2 is 5. Okay. Another rule that we have, and the third rule, is what we call our power law. So again, we start with our base and our exponent, but now there's another exponent. So it's an exponent to an exponent. And in this case, we multiply. So BMN. So again, for example, if I had 2 squared to the 4th, that would be 2 to the 8th because we multiply these together. So this is multiply our exponents. This is subtract. And this is add. So when we multiply our bases, we add our exponents. When we divide the bases, we subtract our exponents. And when we have an exponent to another exponent, we multiply. Okay, so let's go back then to the page that we had before, and let's try implementing these rules to see how they work. So here we go. All right, so we have 2 to the 5th and 2 to the 8th. This means multiplication. So we know then with multiplying, we're going to add our exponents. The base stays the same, stays as a 2. And then we go 5 plus 8, which is 13. Awesome. Okay, I'm going to put a few out here now, and I want you then to pause the video and see how you do with these, and then we can come back and I'll give you the answers. Okay, so pause this here and then come back and we'll take a look at it. All right, so hopefully you're back, and let's take a look at these answers. So my base stays the same, 3. We are dividing here. Remember that fraction is really a division, so we're going to subtract our exponents. 17 minus 9, which would give me 8. Here my base is x, so I'm going to keep it as x. We have an exponent to another exponent, so that means we're going to multiply 4 times 9, which is 36. Now this I'm going to do actually in 2 steps. I see that we have my bases are the same on the top, and we are multiplying. So I'm going to add these together. So 7 plus 6, which is 13. And then I'm going to divide by x to the 8th. And now I know with division, we can subtract our exponents. So 13 minus 8, which is 5. So x to the 5th would be the answer there. This one here, we have an exponent to an exponent. So we have to be pretty careful with this, actually. I want you to realize something here. So let me make it just a little bit bigger here. Okay. So what I want you to be careful about is that even though this 2, it's a leading coefficient, is the name for it, it doesn't have an exponent. There's assumed to be a 1 there. Okay, so I'm actually going to put the marker of 1 because this exponent on the outside is going to touch that exponent there, that 1. It's going to touch this 3 here, and it's going to touch this 5 here, giving me an answer of 2 to the power 4, because 1 times 4 is 4, x to the 3 times 4, which is 12, and then y to the 5 times 4, which is 20. There we go. And I can simplify this up a little bit. I could figure out what 2 to the power 4 is. 2 to the power 4 is 2 times 2 times 2 times 2, which is 16, x to the 12, y to the 20. All right. So this one's a super duper big one. I always like to throw a kind of a bigger question out there. So let's go ahead and figure out what we have here. So I have, this is multiplication, by the way. We can see this top. Okay, we're going to multiply these together. We can start with an 8 times 4, which is 32. And then a to the 1 and a to the 5 would give me a to the 6. And b to the 7 and b to the 9 would give me b to the 16. All over. Okay, 2, remember that has an exponent of 1 on it. This has an exponent of 1 on it. So that's going to be 2 to the power 4. And then a to the power 4. And b to the power 8, because 2 times 4 is 8. All right, so let's just clean this up a little bit here. 32, a to the 6, b to the 16, all over. 2 to the power 4 is 16, a to the 4th, b to the 8th. Okay, now we can actually go ahead and divide these leading coefficients. So 32 divided by 16 is just going to be 2. And then a to the 6th divided by a to the 4th. So division, we know, is subtraction. So 6 minus 4, which is 2. And then b to the 16 divided by b to the 8 is going to be 16 minus 8, which is going to be 8. So that one works out to 2a squared b to the 8. All right, hopefully you did well with that. Let's keep going. Just a little bit more to go. Okay, so there's our rules again. And one of the last things I want to look at is called the distributive property. So the distributive property is when you take what's outside your brackets and you multiply it to what is inside your brackets, to all terms. So it's very important to realize that it's all terms. In this case, 3 gets multiplied to 5x, which is going to give me 15x. And 3 gets multiplied to -9, which is going to give me a -27. And you're done. Once you've multiplied it into the whole bracket, that you've finished your distributive property. Really what it means is you're eliminating the brackets, okay? So distributive property, in other words, means just get rid of your brackets. Okay, so let me put a few more out here so you could give them a try. You're going to have to remember your exponent laws here also. That's why we reviewed them first. Exponent laws also will come into play. So feel free to pause the video right here and then come back to me. All right, so if you're back, let's go and multiply this in. And then this -3, I'm going to have to multiply in. All right, and what do we get? Well, 4 times 2h is 8h, and 4 times 5 is 20. And -3 times 4 is -12. And -3 times a -6h is a positive 16h. All right, now we're not quite done here. We are going to take a moment. We're going to collect like terms. So I have an 8h and an 18h, which is going to give me 26h. And then I have a 20 minus 12, which gives me a positive 8. So 26h plus 8 would be my final answer for there. All right. Same thing down here for C. We're going to take that 3x cubed and multiply it into both of these terms inside the bracket. So 3 times 2 is 6. And x cubed times x squared. So remember, we're timesing here. We're multiplying, which means we're going to add our exponents. So the base stays the same, stays as an x, and then I'm going to add my exponent. So x to the 5th. And then 3 times 11, which is 33. And x cubed times x to the 1 means I'm going to add my exponents there, which is going to be x to the 4. All right, and then I just take a quick look to see if I can combine these, and I can't because this is an x to the 5th and this is an x to the 4th, which means I can't go any further. All right, last one here. We have 3 terms, so it's going to get multiplied into all 3 terms. We are going to have to remember our exponent laws again, but that's okay. So 4 times 2, which is 8. A squared times a to the 1 means we're going to add our exponents. So 2 plus 1 is going to give me a cubed. And then b cubed times b squared, we're going to add those exponents. 3 plus 2, which is 5. Then 4 times -3, which is -12. A squared times a to the 1 is going to give me a cubed. And b cubed will stay as b cubed because there's no other b's there. And then lastly, we get 4 times 5, which is 20. A squared times a to the 1 is going to be a cubed. B cubed times b to the 1 is going to be b to the 4th. And then lastly, we have this c to the 1 here. We have to include that also. So c goes in there too. So I know it's a little bit scrunched. So let me kind of write it again. So we get 8a cubed b to the 5th minus 12a cubed b cubed plus 20a cubed b to the 4th c. There we go. All right. So the big thing is with this is just remembering that you want to take what's outside your brackets and multiply it to everything inside the brackets. Numbers obviously multiply to numbers, and variables multiply to variables, and you have to pay attention to your exponent laws. Okay, so that's the big part of this, is remembering to multiply. When you're multiplying, you are adding your exponents if the bases are the same. Okay, just to remind you a little bit about numeracy too, so that's also very important. These are just some basic skills that you're expected to know. So let's just go over a few of them. The first one being what an LCM is. So a lowest common multiple. So if we had the numbers 3, 5, 7, and 9, what would be my lowest common multiples? Move that down for now. So the lowest common multiple. So if you think about it, there's different ways that you can strive for it. But what you're trying to look for is what number can divide. You can divide it by 3, you could divide it by 5, you could divide it by 7, and you could divide it by 9. So one way you can do that is kind of writing out a list. So I could start with multiples of 3. So 3, 6, 9, 12, 15, 18, 21, 27, where do I go from here? 30, oops, I missed 24, 27, 30, 33, 36, 39, so on. And then 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and so on. 7, 14, 21, 28, 35, and so on. Let me think. What comes next? 7 times 6, which is 42. 7 times 8, which is, or 7 times 7, which is 49. 7 times 8, which is 56, and so on. And then you could do that with the 9s. 9, 18, 27, 36, 45, 54, da, 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 da. Okay, and what you're looking for is a number that is the same, the lowest number that's the same in all your columns. But as you can see, like, this can get to be long and messy. It's one of the ways that we showed you how to do this back in elementary school. It's not a great method. So another way that you can do it is to use prime numbers. So prime numbers, of course, are numbers that are just divisible by 1 in itself. So example, 3 is a prime number. The only thing that will multiply to 3 is 1 and 3. 5 is a prime number. The only thing that multiplies to 5 is 1 and 5. 7 is a prime number. The only thing that multiplies to 7 is 1 and 7. But 9 is not. So 9 is the same thing as 3 times 3. So that's not a prime number. So if I'm trying to figure out what my lowest common multiple will be, what I want to do is I want to make sure that I include all my prime numbers. So if I include 3, so I use this number, and I include 5, I use this number. I include 7, I use this number. And then I've already included a 3, so I can cancel 1 out because I've already used 1. But then I have this other 3, I have to use it again. There we go. Okay, so if I go 3 times 5 times 7 times 3, oh, I'm going to need my calculator for this one. 3 times 5 times 7 times 3. Wow, I get 315. And that would be my lowest common multiple. So as you can see, I would have had to like keep going down really, really far on this list in order to come up with that number. Okay, so let's try a couple. Let's start with this one. So I gave you an example here, like 12 is your lowest common multiple between 4 and 6. But I want to show you how you can use your prime numbers for that. So if I go, okay, so if I go 4 is the same as 2 times 2. and I go 6 is the same as 2 times 3. Then when I go to figure out my number, I'm going to use a 2. Is that it? Okay. I'm going to use this other 2. But I don't need that 2 here because I already used one from out of here. And then times 3. If that's left, I get 2 times 2 times 3, which is 12. Okay, so give this one a try. Sorry, it's not grabbing it. There we go. All right. So between 27, 30, 12, and 15, I want you to give it a try. See if you can find your lowest common multiple. So I'll start with 27. That is 3 times 9, which is 3 times 3 times 3. And 30, which is 3 times 10, which is 3 times 5 times 2. And 12, which is 2 times 2 times 3. And 15, which is 3 times 5. Okay, so I'll show you how this works. I'm going to use a 3 out of this one. So if I use a 3 out of this one, then I can take away that 3, take away that 3, take away that 3, all right there, because I've already used it. And then I'm going to use this next 3, and I don't have any others to cross out. And then I'm going to use this next 3. Again, I don't have any others to cross out. I have a 5 though here, so I'm going to times this by 5. But I have this 5 here, so I can cancel that out. Times 2, which is here, so I can cancel this one out, and then I'm just left with one other 2. So my lowest common multiple would be 3 times 3 times 3 times 5 times 2 times 2. Let's see what that is. 3 times 3 times 3 times 5 times 2 times 2, which is 540 is my lowest common multiple. Okay, now you might be asking yourself, why are we interested in lowest common multiples? Well, the reason why we're interested in that has to do with BEDMAS, has to do with fractions. So just a reminder on BEDMAS, if it's been a while since you've seen it, this is what we call our order of operations. Order of operations, so B stands for brackets, D stands for exponents, D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction. Okay, so this is the order of operations. Order of operations. So if we have a whole bunch of different operations going on in an equation, this kind of lets us know what order we want to do things in. So here, let's try a few then. All right. Wow. So remember, BEDMAS starts with brackets. So I'm going to be looking inside these brackets, and then inside of those brackets, I have more brackets. So I'm looking to the inside bracket. So 11 minus 4, which is going to be 7 squared times 2 plus 9 plus 5 squared. Okay, so 7 squared is going to be 49, and then 49, so that's 49 times 2 inside those brackets. So 49 times 2 is going to be 98, and then plus 9 plus 5 squared, which is 25. Okay, and now we can just add these all up. 98 plus 9 plus 25, 132. Okay, let's go in here. So again, we're going to take a look at what's inside brackets and do that first. So 24 divided by 12, that's going to give me 2 squared, plus, and then in here I have 15 minus 2, so that's going to give me 13 squared times 2, and that's still in brackets. So 13 squared is 13 times 13, which is 196. And then if I times that by 2, I'm going to get 2 squared plus 338. 2 squared is equal to 4. 4 plus 338 is going to be 342. Okay, and down here we get 12 plus 7, which is 19, plus 16. Oh, I'm going to put a bracket here. 16 divided by 2, which is 8, and 8 squared. And then we have times 3 squared, so times 9. Okay, so I have to still work out this part. It's still inside brackets. So 8 squared is the same thing as 64. So I got to go 19 plus 64 first. That gives me 83. And then 83 times 9 is going to be a big number, which is 747. Cool. All right, so it's just about, making sure you do your brackets first and then your exponents, division, multiplication, addition, and subtraction. Now, fractions, we need to remember a little bit also. We will be doing some work with fractions throughout the whole course. So we have to remember how to add fractions. This is where the LCM comes into play. So this lowest common multiple. If I want to add these fractions, I need a common denominator. So whether you want to add or subtract, denominator, there we go. Okay, if you want to add or subtract fractions, you have to have this common denominator. So you look for your lowest common multiple between 3 and 5. And my lowest common multiple between 3 and 5, they're both prime numbers, so you can just multiply them together, which would be 15. Now, I have to write my equivalent fractions that are over 15 now. So this one was over 3. So it went from a 3 to a 15. So I had multiplied that bottom number by 5, which means I need to multiply my top number by 5. 5 times 1, which is 5. And this 5 I multiplied by 3 to get to 15. So I have to multiply my top number by 3, which is 12. And then once you have your common denominators, your denominator stays the same, and you can just add your numerators. So 5 plus 12, which is 17. Okay, same thing if you're subtracting. Okay, no different than the adding. We're still going to find with our common denominator. We have a 6 and we have a 12. I can see that if I just multiply the 6 by 2, it will also become a 12. So 12 must be my common denominator. So 6 times 2 is 12. So 2 times 2 is 4. And this stays as a 7 over 12. Again, once you have your common denominator, it stays the same. Your numerators, though, you're going to subtract. 4 minus 7, which is a negative 3. So negative 3/12. And I can see from there that both of these numbers are divisible by 3. So I could actually write that in lowest common terms as negative 1/4. All right. Now, we can also multiply fractions. So let's start with multiplying fractions. When you multiply fractions, you want to multiply your numerators together and you want to multiply your denominators together. No more do you have to worry about finding a common denominator. That's only with adding or subtracting. So we're going to multiply here 2 times 4, or sorry, 2 times 7, which is 14, and 3 times 11, 33. And it's just like that. So same thing with this one. We could just multiply our numerators together and then our denominators together. But I want you to also pay attention because we can do it this way and then go 2 times 5 or 4 times 5, which is 20, and 25 times 12. Oh, what's 25 times 12? I feel like it's like 300. 25 times 12 is 300. Yeah. Okay, and that can get reduced down. I feel like I can divide 300 by 20. So 300 divided by 20, yeah, is 15. So that's the same thing as 1 over 15. Now, we could have actually figured that out beforehand. I'll just show you how. So we can, if we notice that numbers can reduce down by division on a diagonal or top and bottom, then we can reduce. So for example, 4 goes into 12 3 times. I could replace that 4 with a 1, and 12 divided by 4 is a 3. So that's really 1/3. 5 can go into 25 5 times, so I can replace that 5 with a 1, and I can replace that 25 with a 5. And now if I multiply through, I get 1 times 1, which is 1, and 5 times 3, which is 15. So it brings me to that simplified fraction right away if I simplify it first here when I'm doing this. So I'll show you again in division how that works. So division, a little bit different than multiplication. We can't just go straight through. It doesn't work that way. We're actually going to change our sign. So we write our fraction out, 7/10, change our sign from division to multiplication. Excuse me. Excuse me again. I caught something in my throat. Okay. Sorry. And then take the second fraction, then flip it. So the 6 becomes in the numerator, and the 35 becomes in the denominator. So now, if I was I could multiply these straight through, just like I said before, you know, multiply your tops, multiply your bottoms. But I noticed a couple of things. So for example, 7 goes into 35 5 times. So that becomes a 1. 35 becomes a 5. And I have a 6 and a 10, and both of those are divisible by 2. So let me go 6 divided by 2, which is 3. 10 divided by 2, which is 5. And now if I multiply my tops together, I get 1 times 3, which is 3, and 5 times 5, which is 25. And that gives me a fraction that I don't have to reduce now because it's already in its reduction form. Okay, just a reminder, of course, that you can have a fraction divided by another fraction. So that's what that line means. It means divide. So I would still do this the exact same way. I would start out by writing my first fraction, 1/2. This division, I'm going to change to a multiplication. And then I'm going to flip my second fraction. So the 5 becomes in the numerator, the 3 in the denominator. 1 times 5 is 5. 2 times 3 is 6. And we are done. All right, so just a little bit of a reminder on fractions. And of course, just to end this all off, make it a little bit more complicated, we can also have BEDMAS with fractions. So let me start one here. So we have 5/6 plus 3/4 divided by 3/5 squared. All right. So remember, division has to happen before addition. So when I'm looking at this, I'm actually going to end up doing this first before I'm going to do the addition. So let's leave the 5/6 there, plus, all right. So 3/4 divided by, now this squared, this 2 touches the top and it touches the bottom. So 3 squared is going to be 9, 5 squared is going to be 25. Okay, and then 5/6 plus 3/4 times 25 over 9. And I can simplify that a little bit. I can take that 3 and make it a 1, take that 9 and make it a 3. So I get 5/6 plus 1 times 25, which is 25, and 4 times 3, which is 12. Okay, so now I can do the addition part, but remember with addition, it has to have a common denominator. So my common denominator here is going to be 12. So 6 times 2 is 12, 5 times 2 is 10, plus 25, which means we're going to have 35 over 12 as our final answer. All right, let's try another one. Now this is where I have my brackets right here. So this means I have to do this first. I can work this out too, this exponent. So 5 squared is going to be 25. 6 squared is going to be 36 divided by, okay, I need a common denominator between 8 and 9. And that's going to be 72. So 8 times 9 is 72. 5 times 9 is 45. 9 times 8 is 72. 4 times 8 is 32. All right, 25 over 36 divided by 45 minus 32 is going to be 13 over 72. 25 over 36 times 72 over 13. Okay, so 36 times 2 is 72. So I can cancel that out and put a 1, and cancel this out and put a 2. And then 25 and 13, there's nothing that can cancel there. So 25 times 2 is, oops, sorry. 25 times 2 is going to be 50. 1 times 13 is going to be 13. Okay, I think I'll leave that there. There's a last one there if you want to give it a try, but I feel like it's a little redundant at this part. So this brings us to the end of this lesson, all on algebra and on numeracy. So there's a whole bunch going on. You take your time with it, and if you have any questions, please, of course, reach out, and I will be glad to help you.